Hello students, welcome to Anand Academy. In this video, we will study about the derivation of the electric field of an electric dipole. And here, we will study about the points on the axis. So let's start this video. So here is our electric dipole. So what is electric dipole? Electric dipole is a combination of two charge body of same magnitude but different polarity. As you see, this is plus here and this is minus charge here, and they have a fixed distance. The distance is 2a, and this O is the center of the electric dipole. This is the center, and from this O, if we name it as point A and this is point B, so the distance of AO is A and the distance of OB is A. So that's what the combination of A and A is, 2A. So this derivation is for a point on the axis. So if we extend this point, and here is our point P. This is the point P. And we have to find what is the electric field present at this point P due to this electric dipole. So what we have to do, we have to first mention that the distance between O to P is distance R. So we can write it here. The distance of OP is equal to R. And we know that the distance of OB is equal to A and the distance of OA is equal to A. So based on that, if we have to find the distance of BP, we can write it's equal to OP minus OB. So OP is R and OB is A. So R minus A. Similarly, if we have to find the distance of AP, it's equal to OP plus OA. So here it is R plus A. So the distance of AP and BP is known. Now we have to know one thing. The dipole moment due to the electric dipole, if we mention it as P vector, it's equal to positive charge into the distance between the charge body. So the distance is 2a. We are going to use this relation later. And second thing, we have to know that electric field direction is positive to negative. It means that the direction of electric field, in this case, it's moving from positive to negative. But the direction of electric dipole is from negative to positive. So here we can mention that P direction is negative to positive. So now let's start our derivation. So here we know that the electric field due to a point charge, it's equal to K Q by R square, or it can be also written as 1 by 4 pi epsilon naught Q by R square, as K is equal to 1 by 4 pi epsilon naught. So now you see on this point P, here we have two electric field acting on that P. One is due to this negative charge and another is due to this positive charge. So individually, we will first find the electric field due to this point B and due to the point charge A. So here we can write it. The electric field due to BP is equal to K. Its charge is minus Q and the distance is R square BP. If we substitute the value, we can write minus KQ divided by BP is R minus A. So we can write R minus A whole square. And if we have to find the electric field due to AP, it's equal to K plus Q, because A carries positive charge, into R plus A whole square. So based on this information, we can say that the net electric field acting on this point P is actually the addition of both the electric field due to B and due to A. So that's what we can use, that total electric field is equal to electric field due to BP plus electric field due to AP. So E is equal to K minus Q here by R minus A whole square, and this KQ by R plus A whole square. So E is equal to KQ, we can take common. We can write it as minus 1 by R minus A whole square plus 1 by R plus A whole square. So for that, E is equal to KQ R plus A whole square plus R minus A whole square divided by R minus A whole square and R plus A whole square. So in this derivation, we assume that the distance of R is larger than the distance of A. So from here we can say that A by R is almost equal to 0. So now based on this relation, if we continue here, we can say that E is equal to KQ minus R square minus A square minus 2AR plus R square plus A square minus 2AR divided by R square minus A square whole square. So here we can cancel R square, A square. So for that we can write it as E is equal to KQ minus 4AR divided by R square minus A square whole square. Now this R square minus A square, we can write it as R square 1 minus A square by R square. So we can use this relation in our solving. So it can be written as KQ minus 4AR divided by R square 1 minus A square by R square, and then outside is whole square. So for that, E is equal to KQ minus 4AR divided by R to the power 4 1 minus A square by R square whole square. So this A square by R square is almost equal to 0 based on our relation A by R tends to 0. So now this E is equal to KQ minus 4AR by R to the power 4. So this R and R to the power 4 will get cancelled. So it's equal to, E is equal to KQ into minus 4A divided by RQ. So further, if we have to write this relation in terms of electric dipole, we can say that P is equal to Q into 2A. So E can be written as minus 2 into K into Q into 2A by RQ. So it can be written as E is equal to 2K P vector by RQ. So here the negative, this negative is removed. Why? Because the direction of electric field and the electric dipole, its negative direction. So that's what we can remove this negative sign. And this is our derivation of the electric field formula on the axis. It can be also written as 1 by 4 pi epsilon naught 2p by r cube. Both are same, only the k value is changed to 1 by 4 pi epsilon naught. Thank you for watching this video. If you like this video, you can subscribe to my YouTube channel and like it, comment it. Thanks a lot.